Hello, good afternoon, everyone. Assalamualaikum. Okay, today we will cover two topics. So we just wait. I think can we can we just wait another few minutes for the students to come in before we start. Today we'll cover two topics. I've given you the slides. Topic number 6 and topic number 7. Yes. Share the screen.
Recording in progress.
We've got a few more minutes. So today we'll cover the topic on call it decision making. If you refer to the textbook, this topic still topic number 6. The title is optimization and simulation. Okay, I think we can continue. Today, okay, we want to, okay, as we have, everyone clear? Can you hear me? No responses so far?
Yeah, we can hear you.
Okay, okay. Okay, today we'll talk about decision making. As we mentioned, decision making, there are a few methods how to make decisions. So we begin with model-based decision making. We have learned about descriptive and predictive analytics. Now we move into prescriptive analytics. Prescriptive analytics is how to make decisions based on what we gathered from descriptive analytics. Descriptive analytics is about understanding where you are, your position, your current position, and then based on the past and historical records, and then predictive analytics, we look into the future. So with these choices, we move on to prescriptive analytics. We need to make the best possible decision. So prescriptive analytics is about making decision using some kind of analytical model. So we have moved from descriptive, predictive, now we move into prescriptive analytics. For example, profit maximization. We also learned about utility theory, where we have full utilization instead of just profit or monetary gain. So this is based on, okay, this is just example from INFORMS. INFORMS is Institute for Organizational Research and Management Science. So they gave an example in the book on the decision support system for ship routing. So it is based on mathematical models. Yeah. Okay, but when we want to make decisions, when we want to make decisions, the main thing that the main problem is about how do you identify your problem? Yeah, how do you identify your problem? And then you need to analyze your environment. How do you identify the problem? What is the problem that you want to solve? Sometimes the problem seems like a problem, but that is not the problem. They are just symptoms. Symptoms are things that you can see directly, is on the surface, but problem is the matter that you need to solve. You don't solve symptoms. We solve problems. So we need to identify problem. Even when you do research later on, when maybe some of you have started with your project paper or business research method, it is the main issue in any research is understanding your problem, is identifying the problem. Yes, for example, I usually give the same example, like we have dengue fever. In Malaysia, we have dengue fever. Dengue fever is the problem. Is caused by microbes. Uh, it, uh, I don't remember the microbes and names. And from um, mosquitoes and so on. So those are the problem. But when you when you suffer from dengue, you have some rashes, your temperature increase, you have fever, you have stomach ache, you have headache. And so those are just symptoms. So if you put some ointment or lotion for your rashes, it doesn't solve the problem. They are just symptoms. If you take certain paracetamol to lower down your temperature, it doesn't solve the problem because temperature for dengue fever is not that high anyway. So you need to solve the problem. You can see that your platelet count was lower. So those are just still symptoms. So you need to identify the problem. And then once you have identified the problem, you need to look into environmental analysis. Why do we need to you need to see the factors that affect the affecting factors surrounding your problem. Yeah, so what are the issues that you can see? And then you need to identify variables. Yeah, variables. You need to identify variables. So go back again. I think we have covered in the first class. What are variables? What are variables? How do you see how do you identify your variables? What are the variables? Anybody? Yeah, Ernest, what are variables, Ernest?
I don't remember.
You don't remember. Anybody else? Wang Mei Wei? And what are variables? Any Fang? Yes,
Probably the factor that we are changing.
the factors that you are changing. Is it variables? Is that variables? Uh, Anybody else?
Maybe doctor is an element that is highest chance to change, so we call it a variable.
Okay, elements that highest chance to change. Is it variable? Okay, somebody else? Tasha? What are variables? How do you identify variables? First, you need to know what are variables. Balkis?
Something that changes.
Things that changes. Okay. Variables are things that interest us, matters or factors that interest us. So how do you look into factors that interest us? First, we look into the problem identification. We can see this is the problem. And then from this problem, see things that interest us. what are the things that interest us. Yeah, variables are things that interest us. Yeah, so maybe the fluctuation of the currency, or it interests us, that are variables. Or the income, the GDP of the country, it is variables. Or maybe the number of customers that left us and then move, or churning rate and moving to another company. That is things that interest us. So things that interest us are variables. And then these variables usually are dynamic, meaning there is the figures change. That is called observations. Yeah, so those called observations. So variables, you can refer back to the old notes, previous notes, things that interest us. And then these variables, I'll use my whiteboard. Yeah. Factors. Meaning that things that we would like to see. These are variables. And then variables variables are dynamic changes. And then there are also variables that are fixed. But we say variables are dynamic. Most variables are dynamic. So as they are dynamic, we can see observations. We can monitor. We can observe. We can observe variables. So changes in the variables are called observations. Changes in variables are called variables. We call it observation. So we observe the changes in the variables. Yes, so we call observation. So the variables are dynamic, and then there are changes in the variables, which we call observations. So this is why we call variables can fluctuate up and down. Yeah, so sometimes we have an S curve. For example, product that started, we have an S curve. Yeah, so these are changes that we can observe. Changes in the variables are called observations. Yeah, so variables are things that interest us, that make us want to monitor this. Those are variables. Yeah. Okay. Everybody clear? So these are variables. We need to identify what are the variables, and then so that we can develop an influence diagram or cognitive map. We can see, okay, this is the things that we want to see, and then what are the variables. So from the predictive analytics, we can have more information to better forecast and predict and so on. So we have multiple model where we have static versus dynamic model that keep on changing. And then the decision system can include several models. So we'll go back later how to. So major modeling issues when you look into models is actually you look into how do we manage the model, how do we make sure the integrity and applicability of the models. So we have model-based management system. When we develop a model, for example, a linear programming can be a model, a formula such as y, this is mx plus c, yeah, for example, and then you can have certain figures as y, certain figures is x, certain figures as c, for example. So whenever there are changes in, or we can call it y is equal to f x, and then is equal to say when, so maybe it is a profitability, and then you can have revenue, for example, you can have revenue, profit, or break even. Yeah, break even. So we have x, and then we have c. Okay, let's see. Give you an example, and just give you an example of costing. Yeah, of costing. So say example, we have profit, equals variable cost plus fixed cost. Yeah, variable profit is equal variable plus fixed cost. So this is y, this is mx, because variable cost, okay, profit is equal to unit variable cost, see, unit variable cost times the number of unit plus fixed cost. Yeah, so profit can be calculated as unit variable cost times the number of units that you produce plus the fixed cost. So these are models that you need to make sure that you maintain the integrity of the model that you apply. And then there is also knowledge-based modeling. It does not confine itself to quantitative modeling, but you can also have qualitative modeling. You can have expert system. Expert system use qualitative or knowledge-based model. Yeah, knowledge-based model. For example, in medicine, in certain area where you have qualitative model to decide. The knowledge-based model is based on ontology or taxonomy, so you can have heuristic to make decisions. Heuristics. Make decision if this happen. So we have learned this in AI topic in our MIS, where we have forward chaining and backward chaining. So this is major issues in modeling, where we look into, we need to maintain the integrity and applicability of the models, and then how do we manage the models, and then decision support system also uses quantitative model, but it also use qualitative model. Yeah. So there are several methods of model today. We have cloud-based modeling tools. We have transparent model. We have visual model, multidimensional model. We have difference diagram and so on. Yeah. So we move on. So some categories of model, for example, in optimization of problem with few alternatives, we need to find solution from a number of sample. We have decision tables, decision tree, hierarchical tables, yeah, analytic hierarchy process. So decision table, decision tree is, I think we'll show later. Yeah? So it is a tree-based decision model. Yeah, if it is, for example, people applying for loan. If they apply for the loan, okay, if the age is correct, yes. If the age is exceed or lower than applicable, so no. So if age is correct, yes, and then you see what is the income. Income is within the amount approved or allowable, yes. If the amount is less than allowable, no. So that is a decision tree model. Yeah, decision tree model. So you break into decisions. And then we have optimization via algorithm. So we use linear or mathematical programming model, the one that I showed to you when you look into, for example, break-even numbers, profitability, and so on. We have linear models. And then we have optimization model, for example, economic ordering quantity EOQ. Yeah, economic ordering quantity, there is formula into economic ordering quantity, where you want to make orders for the stock, when you make order for the stock, and then how much you economic ordering quantity model. And then simulation, we have what if solution and so on. And then we have heuristic model, like I mentioned just now, using rules, yeah, expert system, maybe physician or engineers. They have qualitative knowledge. You develop into a knowledge base, and you develop heuristic programming. Is what we call it rule of thumb programming. Yeah, heuristic means rule of thumb. So you can also have Markov analysis, predictive model, and other model. For example, what if case situation, financial modeling, waiting lines. Yeah, so this is categories of model that we can use. Okay. So how do we? There are two types of model. One is non-quantitative model, qualitative models, which is knowledge-based model, and then we also have quantitative models, which link decision variables. Okay. We learn just now we talk about variables. Variables are things that interest us. That from variables we can have observations. From the observations we can monitor the observations. From these observations we can tie them up. We can link the variables to another variables. There is relationship between variables to another variables. The mathematical relationship just now, for example, in linear modeling, linear programming, you have fx is equal to mx plus c, for example. This is very basic one. Yeah, so c, for example, is the fixed cost where it at the it is at the y-axis, so it will chart at the y-axis. Let me draw something here. Okay, so we have here. So whatever it is, you will surpass the y-axis because this is your total cost. This is your cost, total cost. Yeah. And then you can see there is a total cost, and then the M is uh, your actually the variable cost per unit. Yeah, and then you times the number of units, and then C is your fixed cost here. Yeah, so this is your fixed cost here. So this part is your fixed cost. So whenever unit change, the unit increase, you can see the variable cost increase. So you need in order to look into your break-even point, there is we call it there is another formula where you can see the total revenue. Total revenue will be exceeding your fixed cost. Then you can see the break-even where the number of unit that it will surpass the break-even. Something like this. So at this point, you will break even. Exceeding this, below this, you're making loss. Yeah. Something. Okay. That is the mathematical link for your decision variables. Now we look into the target variables that you look at is the dependent variables, or we call it result variables. This is your result variables. So this is your independent variables. You have two independent variables. Okay, what is the difference between the main difference between independent variables and dependent variables? Anybody? Yes, James. What is the difference? I have running nose today. Okay, what is the difference between the independent variables and dependent variable?
I could only think, Doctor, that maybe the dependent has I mean, how it changes is influenced by other variables.
Yes, dependent variables is affected by other variables. The observation of the dependent variable or result variable depends on the other variables. So it depends on the other components, other components. So now we look into independent variables. What are the independent variables? Anybody else? What are the independent variables? How do you define? How could you expect which is the dependent variable? Now you know dependent variables. It depends on the other factors. But what are the independent variables? Ernest? Oh, Tasha? Balkis?
things that are not relying on the variable.
Okay, independent variables are variables that are not being affected by any. Meaning it is independent. They are independent. They are not being affected by any other variables. It is on their own. For example, you want to increase your, say you work in a bank, then you want to increase your finance rate, your financing rate. Is it dependent or independent? Your financing rate, your lending rate, for example, base lending rate or base financing rate. Is it independent or dependent? Base.
It's dependent.
Dependent. Independent.
Dependent.
Dependent or independent. Base lending rate. What does it depends on? Okay, today we talk about OPR. Overnight policy rate. Overnight policy rate, when they decide to make overnight policy rate, it is independent or dependent?
I think that one is in independence, while base lending rate is something that fixed by the bank one itself.
Base lending rate also base lending rate is fixed by the bank, so it is fixed. It is fixed by they could also be independent, but they could also be dependent because the bank fixed base lending rate based on the number, the OPR, the rate that they have to incur when they borrow from another bank. So, but when they put up their OPR, the OPR is independent variables. Why they put OPR? Because they look into the dependent variables that will result from the independent variables. Okay, but basically independent variables are not affected by any other variables. It is decision variables. Yeah, they are decision variables. There are two types of independent variables. One is decision variables. Decision variables is you make your own decision. The managers make decision. Managers make decision and put the variables there. Although the managers make decision with the expectation of the dependent variables, but the independent variables come first. The dependent come after. You can see this is before. You decide this is before. This is after. How do you define which is dependent variable, which is independent variable? This before and after. Is it clear? James or Tan Wee Kwan? Which one you do first? Independent variables or dependent variable? Dependent variables come after. Meaning, when you make decision, this will come after you decide. This you come before you decide. Okay, you decide this. You decide decision variables affected by the decision variables. It will cause the. This is the if. This is cause. This is the effect.
So from priority wise, Doctor, that means we start with the independent first.
Okay, priority wise, we start with the independent first. Why? How do we start the independent? Because we okay, we will learn later. Yeah? We learn about that's what if analysis and target analysis, but we will cover that later. Okay, when you make decision variables, when you make decision, what is your target? Say when you want to mark up your price, what is your target? Okay, markup. See, example, markup. Anybody understand? Everybody understand what is a markup? Markup is say you do cost plus pricing. What is cost plus pricing? What is cost plus pricing?
Cost plus profit, then you get your pricing, right?
Yes, cost plus pricing is your cost. You have your total cost, you plus your margin, target margin. I put it target margin. Then you get your pricing. Okay, cost plus pricing. Cost plus pricing. Okay, you will target your price. You will do your pricing based on your target margin. Okay, from this, so you will make your price here. This is your price. You want to set your price. Setting your price, you determine what will be your target margin. How do you calculate your target margin? It's just estimation based on your strategic decisions. Based on your strategic decisions, the bosses, the CEOs want you to make margin of 15% increase. So you increase 15%. So you calculate your total cost and then you mark up with your target margin, you get your price. You get price. And then here, dependent variables will be your profit, for example. How do you, so you have a target profit, then you work backward to make decision variables to make your price. Decision variables is you make before. Yeah, we make before. And then dependent variables or result variables is the result after. I hope everyone is clear. James, clear? Tasha, clear?
Yes,
Yeah.
Doctor.
Yes, it's easy, right? Okay, besides the decision variables, there are also things that we call it uncontrollable variables. What are uncontrollable variables? Anybody can just share with us?
The economic and political factors.
Economic and political factors. Okay. So how do we put in figures? For example, like we have tax, for example, tax decision. We have, say, for example, you have GST. For example, GST doesn't affect the custom. Actually, we have SSD also actually doesn't affect the company. It affects the customers. Whatever are the costs that you cannot control. For example, exchange rate, currency exchange rate. Happens to be you buy materials where your total cost comes in US dollars, for example, and then you have exchange rate. Today, exchange rate is coming at 4.7. Yeah, so 1 ringgit is $1 is 4.7 ringgit, for example. So exchange rate or other factors are called uncontrollable variables. Why is it called uncontrollable variables? Because it cannot be controlled by the company. So you have total cost here, and you have target margin, and then you work out your pricing so that you have a target profit. You have a target profit here. Yeah, dependent variables, your target profit. And then this is the mathematical relationship. How do you arrive to this target profit? Profit is actually total cost minus total revenue minus total cost. You get the profit. Yeah, profit is total revenue minus total cost in the total. And then total revenue is what? What is total revenue? Total revenue is equals to selling price times unit, number of units, yeah, and then you minus so do we have a bracket here? We have total cost, total fixed cost, variable cost times unit, and then you minus your fixed cost. Fixed cost is a fixed. Yeah. Okay, by the way, what is fixed cost actually? Does fixed cost fluctuate? Does fixed cost fluctuate? Is it fixed or it change? Does it change? Anybody? Balkis or Ernest? Does fixed cost fluctuate? Ernest?
I think it can change, but not often. Like for example, that your overhead salary can change, you know, with increment and all that, but it doesn't change with your production rate, I guess, within the same year or something.
Okay, that is an answer from Ernest. Anybody else? James? Does fixed cost change, James?
Yeah, I would say no, it doesn't change, but it changes only based on volume per unit price, for example.
Okay, anybody else have a different answer? Tasha?
Same with NS.
Okay. Fixed cost does change, but fixed cost doesn't change according to unit of production. Variable cost change according to unit of production. So for example, I showed the formula just now, MX plus C, M is the variable cost, C is the unit. So variable cost depends on the unit of production. Fixed cost doesn't depend on the unit of production, but it still change. It can change over time. Your rental can be changed because your landlord today maybe decided to increase your rental, or your utility, the tariff of electricity increase. So you have a standard usage for number of square feet. Usually you measure electricity by square feet because you have lighting based on your square feet, your air condition based on your square feet, there is electricity based on your square feet. You don't change the size of your factory, so the fixed cost is fixed, but they change the tariff. When they change the tariff, your fixed cost change. Or whatever it is, but fixed cost change. Fixed cost does change, but fixed cost does not change according to the unit of production. It doesn't affect by unit of production here. So like James explained just now, it was the other way around, yeah, James? It
Yep.
doesn't change according to unit of production. Fixed cost doesn't change according to unit production. Variable cost change by unit of production. Meaning when you increase your production, your volume, your variable cost will change. Total variable cost, but fixed cost doesn't change. Yeah. So that is so fixed cost and variable cost. Those are your decision variables. You can you can increase your cost, you can reduce your cost. That is your decision variables. And then there are uncontrollable variables, which is the exchange rate and some other things, maybe other factors, import duties, yeah, duties. Besides exchange rate, you have duties. When you import materials, you have duties. So these are exchange rate, and then we have uncontrollable variables, and then there is mathematical relationship. For example, this is a mathematical relationship that I showed you down there, the mathematical relationship, and then we'll produce the result variable, which is the profit, the target here. Yeah, the mathematical relationship to produce the variable. So this is models. This is models. And then we have intermediate variables. Intermediate variables is, I don't have an example here, but same situation where, say, another variables that you need to pass through before you get to the result variables, interim variables, yeah, meaning the intermediate variables. For example, once you have this profit, and then profit can be intermediate variables, or the pricing can be intermediate variables, yeah, because your total cost is also depends on other factors, and then your target margin. So you determine from these decision variables. So the pricing can be here, and then the dependent variables. So in the intermediate variables is variables in between. Yeah, this is when you look at it forward. So you have independent variables, you have which comprise of decision variables and uncontrollable variables. You have mathematical relationship to reproduce the dependent variables. You can also work backward. We'll learn later. We work backward because we have dependent variable first, and then you decide what would be your decision variables. In making decisions, this is how you make decision. You target the result, and then you work backward, or you predict, you have the price, and then you can expect the dependent variables move forward. Okay. Any questions so far on the models? Okay, we'll move on. Okay, these are examples of component models. For example, financial investment, the decision variable is how much investment, what are the investment alternatives, and how much investment you want to put into certain alternatives. So you look into total profit, the result variable. The target is the total profit, risk, the return on investment that you targeted, earnings per share, PE, and then liquidity level, and then uncontrollable variable can include inflation rate, prime rate, competition. Yeah. In marketing, your decision variable is how much you want to put into your advertising budget. How much you want to, and then where do you want to advertise? So the result variable is how want to achieve. You want to achieve certain level, certain percentage of market share, certain level of customer satisfaction. Uncontrollable variables will be the customer's income. The company doesn't have uh, control on the customer's income or competitors' actions. So this is uncontrollable variables. Manufacturing, what and how much to produce, what is the inventory level, or compensation program that you give to your staff. The result variable will be the total cost, or total cost depends on fixed cost and variable cost. Fixed cost does not depend on the volume. The variable cost depends on the volume, but fixed cost can be also fluctuate. And then quality level, employee satisfaction. The uncontrollable variable is the machine capacity. Sometimes you buy machines, but the capacity is within so and so. So there is a range for the machine capacity. The technology that comes and material prices. Material prices sometimes depends on exchange rate, depends on the logistic cost and so on. So material prices fluctuate. For example, like we have chicken prices, flour prices, and then say egg prices. Yeah, so it fluctuates. Accounting, for you want to use the decision variables is audit schedule or use of computers and so on. Yeah, so the uncontrollable variables, tax rates, legal requirements, and result variables is data processing costs and so on. Okay, these are examples of, you can see the examples of the area, the decision variables, result variables, and uncontrollable variables. Yeah. So the component of quantitative model are linked together into an algebraic expression of equation. So you can see P is profit, R is revenue, and C is cost. So this is another example, simple present value formulation. Present value, it depends on the future cash flow. You can do discounted cash flow, for example, DCF, discounted cash flow. I think you learn discounted cash flow in accounting, in accounting and finance, discounted cash flow. And then this is based on your interest, the interest rate, and then the number of period, and then you can. So the value of 100,000 today in 5 years time at the interest of 0.1% will be only 62,092. So this is number of years. Yeah. Yeah. So that is the present value. For example, if you keep today, you spend, if you were to receive today 100,000, or you receive the 100,000 over a 5 years period, at the end of the 5 years period, the worth of 100,000 is only 62,000. The value you bring it today. So this call it net present value. Yeah, this is the formula. So you can, what are the variables here? The variables we have, which is the interest rate, which is uncontrollable variables. And then the present value, the future cash flow is the control variables. Number of years is the controllable variables. Yeah. Okay, any question on the modeling, financial models? Financial models depends on, actually depends on, it's not so, it is, we use computers to calculate, but the formula comes from the field. The formula, for example, economic ordering quantity, the profit rate, the break-even comes from the field, yeah, from the area of interest, yeah, area that you study. marketing and so on. So you need to know the formula, and then you apply them in computing models. Yeah. You okay? Any questions so far? Tasha, Ernest, James.
No question.
No.
Okay. Okay. Yes. So if it's given, because it usually if it's given in exam, the uh formula will be given, and then you need to identify which is the dependent variables or independent variables. I think by now you will know what are the decision variables, what are the uncontrollable variables, and then what are the dependent variables. Yeah, and then usually the formula will be given if it is an exam, but in real life the formula is not given. You need to know your mathematical model for your area. Okay, when you want to make decisions, there are things that concerns us that in when we make decisions, there are three situations. There are three situations. One, we call it certainty. Certainty is we have complete knowledge about the situation, and then the relationship between the potential outcome is known, and then all the potential outcomes are known, and then so we can yield optimal solution. So when we have a formula, we know we have complete knowledge of the situation. So if we uh, produce a certain product, and then all this product will be sold, we have certainty that all product will be sold. For usually, for example, in projects, yeah, we have complete knowledge about uh, the design structure. We know how much the capacity, the exact capacity of our machine, and then so how if we put input of certain amount, what will be the output? So all these potential outcomes are known. That is called certainty. Yeah, certainty. We have certainty. Another situation we call it uncertainty. Uncertainty is several outcomes. There are many outcomes and several outcomes for each decision, and then the probability is unknown. You don't know at all. So we have knowledge will lead to less uncertainty. Okay, this is another point. Okay, several outcomes of the decision, the decisions. So we don't have no knowledge about the probability of each outcome. If you make decision A, we do not know what will be the probability, whether it will, for example, whether it will rain today or not. Maybe there is probability. You can look into the map, the meteorological department, but say whether there will be earthquake in a certain location today, we wouldn't know. So that is uncertainty. These are uncertainty. And then there is another area we call it risk probabilistic decision making, where probability for several outcomes of occurring are known. Probability is known. Yeah, so when we have uncertainty, when we have certain knowledge, it will lead to less uncertainty. It will move to risk analysis. Yeah, when we increase of the level uncertainty, increase to with knowledge, it will become to risk where we can have expected value. Yeah, so we have certainty. Let's see here. Certainty where we have complete knowledge. When we increase our knowledge, and when we decrease our knowledge, we lose knowledge, we move into risk, and then we become uncertain. Total ignorance. When we begin with uncertainty, when we increase knowledge, we have certain probabilistic figures that we can calculate, and then until to another level, we have complete knowledge, 100%. We know every situation. We have complete knowledge. So decision making based on these are different. When you want to make uncertainty, maybe you use Monte Carlo model, risk analysis. You have a few risk probabilistic models, and then uncertainty. You can use what if scenario, or you can use decision tree, yeah, for certainty models. So the most popular decision models, it uses spreadsheet. Spreadsheet is easier. Okay, it's flexible to use. There are powerful functions, add-in functions, programmability. Programmability, you can use macros, you can do what if analysis and goal seeking. You can have simple database management, simplest integration of model and data. You can incorporate both static and dynamic model. The most common spreadsheet comes in Microsoft Excel or the older Lotus 123. Okay, two things that I want to point out here is the what if analysis and goal seeking. What is the difference between what if analysis and goal seeking? Okay, for what if analysis, okay, when you talk about, okay, we have here decision variables. Remember, we learned just now decision variables and result variables. Always remember these things, decision variables, result variables, and then uncontrollable variables. Decision variables and uncontrollable variables are independent variables. Result variables is a dependent variables. Yeah. Okay, which one begins? Okay, what if analysis? Where do you begin? With result variable or decision variables? Okay, start with what if analysis. If we do what if analysis, where do you begin? With decision variables or we begin with the result variables? Decision variables. What if analysis? You begin with decision variables. Also, goal seeking variables?
The result.
Result variable. So this is what if analysis is I need to do this. Yeah. What if analysis is you begin with decision variables and goal seeking is you look at result variables. So you can work both ways. Depends on your situation. So if, okay, give you a situation. This can come in your case study. If you have a case study in your exam, for example, your board of directors decided they want to make, now you are making a margin of say 10 million per year, for example, a profit of 10 million per year. You make a profit of 10 million per year. Now, the management decided that you have to increase by 20%. Is it decision variables or result variable?
Result.
Result variables. Yeah, this is for result variables. So you are making 10 million a year. Now you have to increase 20%. To increase 20%, you have 12 million per year. And then we have 12 million per year. So your result variable is 10 million, 12 million per year. And then you need to work backward to get your decision variable. What volume should you produce? What will be your cost? What will be your selling price? You work backward. That is goal seeking. Say, what if analysis? So in the situation where the company decided to increase the markup, today you are marking up at 30%. Your say food cost, you mark up at 30%. Yeah. So you have a restaurant, you mark up the food cost at 30%. And then you have your salaries, of course. And then, but just your food cost, your material cost, you mark up by 30%. And then you need to calculate how much profit do you want to make. Is it goal seeking or what if analysis?
What if?
What if analysis? And what if analysis, example is you currently mark up 30%. Or now you want to increase or 20%, you increase to 30%. When you increase the 30%, your markup pricing, your markup for your pricing, then what we will be, so because when you increase your markup, your contribution margin will increase. And then from the contribution margin, you will less off your fixed cost. From the fixed cost, you can get your profit. So you will get so that is what if analysis. So this is forward, this is backward. Decision variable, what if analysis is forward. Yeah, this is forward. Goal seeking is backward. You decide, you begin with the goal, and then you work backward. So essentially it's the same thing, just which direction you want to work. You use the same formula. So you just change you want to find Y or you want to find X. Yeah, find Y. For example, Y is equal to, then find Y. There is a formula, find Y. Or you have find X. You decide which is what is the find X. Y is given, you want to find X. Okay. That is spreadsheet. So this is an example, simple loan calculation payment here. Example here, this is the formula here is the loan amount. So you need to determine what is the loan amount and then what is the monthly payment. So you can work forward, meaning that you from the monthly loan payment, you can see what is the loan amount, or from the loan amount, you can work backward. You can decide what is the monthly loan payment. Yeah, so this is an example given. You can test this in your Excel. You can just test this in your Excel. The formula is given there. We will not, because Excel is I think you can do Excel on your own. Yeah. Okay. Then mathematical programming. Yeah. So we have optimization, but we are mathematical programming. I think we given some example today. Mathematical programming is about a family of tools designed to solve managerial problem, where decision maker need to allocate scarce resource among competitive activities to optimize a measurable goal. So, and then you need to find the best possible solution model to a program. So you will develop mathematical model. So for example, like you have multiple number of products. You have two products, product A and product B. And then product A have certain margin, have certain, there is cost to product A, so therefore it will be have certain margin. Product B have cost, and then therefore it will have another margin for product A. So you want to find what is the most optimizing or optimized, or how do you can maximize your resources so that you have to have provide the maximum profitability for the two products. So you can have something like this. So you have situation on linear programming. We have limited quantity of economic resources, and then the resources are used in the production of products. And then there are two or more ways to use the resources, and each activity will yield a return in terms of the goal. So allocation is usually restricted by the constraint, because say you only have certain amount of fund to buy product cost, buy the raw material for product A, and then if you buy more material for product A, you will have lesser amount of to pay for the material for product B, something like that. So allocation are restricted by the constraint. We have an example later, so we'll go to the example, but for the time being, just this is the factors that you need to, the characteristic that you need to understand. We have limited quantity of economic resources. We have scarcity. For example, companies have limited amount of fund in their banks, and then so this amount of fund, even the number of manpower or number of raw materials can produce two products. We have limited quantity of the economic resources, and then these economic resources are going to be used to produce product or services. And then there will be two more ways you can produce one product, two products or three products, two or more ways to use the resources, and each activity will yield a return. Yeah, so every activity, if you produce product A, there will be a return for product A based on the margin. For product A, maybe product A have lesser margin compared to product B. Yeah, for example. And then the allocation is restricted by the constraint because there is limited quantity of resources. So it can be also limited resources, limited by time. Yeah. So number of days, you only have 20 days of working in a month. So you production of A, maybe you need to have some lead time, and so there will be some number of days that you have to spend for certain product A, and then number of to be spent on product B. For example, you have single line or two lines and so on. So you will be restricted by the constraints. So how do you, what is the linear programming steps is to identify the decision variables. What are decision variables? I think we have been repeating this. Decision variables are the variables independent, are the independent variables that you decide. And then you look into the objective function, what is the function, and coefficient the function, and then you look into the constraints. So you can put this formula in Excel or Lindo. Lindo is a software. Run the model and observe the result. This is an example given in the textbook. Product mix linear programming, MBI corporation. The decision variable is how many computers to build. You have two type of mainframe computers, CC7 and CC8. The constraints are labor, material, and marketing limits. Labor, because the CC7 will take 300 labor days. 300 labor days. CC8 is 500 labor days. Yeah, so there is a limit 200,000. So we have been from less or equal to 200,000, maximum 200,000 per month labor days. Labor days, what is labor days? Labor days is labor time days actually. Labor time days. Number of labor time number of days. If you have 5%, everybody working and the number of days, so 5 times, say, each one of them working at 20 days in a month, so 5 times 20 will be 100 labor days. Yeah, 100 labor days. 300 labor days maybe is about 15% working in 20 days in a month. 15 times 300, it should be 300, yeah, 300. 15 times 20 will be 300. So this is 15 times 20, or the other way around. This is CC8 will be 500 labor days. Less or equals, so the maximum is 200,000. Materials, number of in dollars, the materials for CC7 is 10,000, materials for CC8 is 15,000. So, but your capacity, your resources are only to spend 8 million per month. The maximum 8 million per month. So you will, in terms of units, you will produce 1 unit of CC7, and then 1 unit of CC8. So the limit is you can have 100 with this amount labor and material. You can only produce 1 unit. You will get $8,000 profit margin. And then for CC8, for 1 unit, you spend 500 labor days, materials of 15,000, your profit will be 12,000. And then in maximum number of unit for, it can be more or equals 100, and then units for CC8 is more equal to 100. So this is the formula. So you need to maximize Z profit based on the constraint. So X1 will be units to produce for CC7, X2 units to produce CC8. The result variable total profit 8,000, because what is 8,000? 8,000 is number of profit, amount of profit here. Yeah, 12,000. Your total profit will be the number of profit times the number of units that you produce, CC7, and then the amount of profit and the amount of units that you produce for CC8. So the constraint or uncontrollable is that the maximum amount or number of hours is only 200,000. So 300 X1 plus 500 X2 equals and less 200,000. And then the amount of resources that you can buy in a month, maximum is 8,000. So you have 10,000 X1 plus 15,000 X2 is equals or more, equals or less 8,000. So you can produce X1 more than 100, you can produce X2 more than 200. So this is the formula, the decision variables, the formula is given here. And then in order to use this, you need to download, you need to have an add-in, yeah, add-in solver. You go, let me show you. Any questions so far? Yes, any questions so far? These are just mathematical programming that we learn in our school, in school. I'll show you the Excel. Hold on. Stop share first. Open up Excel. Okay. Okay, this is the Excel. Okay, I'll show you my Excel. I haven't done the task yet, but I'll show you how to use the add-in. Okay, this is my Excel. Okay, just for you to test, you go to files here. Okay, you can see my Excel, right?
Yes, we can.
Okay, you go to file here, and then you might be using different version of Excel, but basically it's the same thing. You go at the bottom, there is more. You can go for option. From at this option, you can see at the bottom, oh here, this side, add-ins. You can see add-ins here. Yeah, let's say add-ins. At the bottom, you can see Excel add-ins. You just go, and then you tick this analysis toolpack, analysis toolpack, Visual Basic, and then VBA solver add-in. Or you want to have Euro currency tools, you can also do that. You click OK, and then you click OK. Yeah, you click OK. So once you have that, you will have, you can see your data. You go to your data. At this side, you can, this end, you can see that we have a solver and we have data analysis. So solver, you can put in the formula. Yeah, you can use this solver parameters. You put in the parameters. Okay, how do you put the parameters? I'll close this first and go back to our slide just now. Where is my slide? Okay. Okay, this is the once you are at solver, this is what you use. You put the you put in the these figures first. Yeah, the figures here, total profit and so on. You put total consumed unit, and then you put in the objective. You put the parameters based on the constraint, and then you can test them. Okay. Okay, this is just an example. There is another example that I've given you in your slide. Yeah, so you can just test. But for this, for the class, I'll just use this. But in your notes, there are other examples that you can use using Excel as well. Yeah. Okay, any question? This is just linear programming. Linear programming is the thing that we learn, I think, uh, in our algebra class. Yeah. Any question, Tasha, Ernest, James?
No.
No question.
No question. It's easy. Like, yeah, this is what we have learned. Only we put them into Excel, and then you can use. I just showed you how to use the add-in in Excel. You can install in the Excel, so you can use it. It's paid. You have paid it with your Excel. Okay, and then common optimization models. We don't cover here because, but we can get this information. For example, economic order quantity. You can check in your uh, accounting class. I don't remember because I used to use this formula as well. Economic ordering quantity, minimizing cost of shipment, replacement. You do capital budgeting, non-linear programming. We have that. And then we have linear integral programming, maximizing rate of return, yeah, co-programming. So these are common optimization models. So this is based on the area of your subject. Okay, and then multiple goals and sensitivity analysis. You can have multiple goals. Just now we have multiple goals and then simple goals. And then how do you attain simultaneous? And then methods of ending multiple goals, you can use goal programming. You have a goal and then you work backward. Expression goals using, for example, linear programming where you have constraint, or you can put in point system, you give points. Another way that also use points is utility theory. We will cover utility theory in topic 7. After this, we will cover topic 7. Utility theory is we don't just look at the financial return, we look into other non-financial aspects when you want to make decision. Maybe we talk about economic, society, goals, and or SDG and so on. So we have utility theories. We cover utility theories in topic 7. So certain difficulties may arise when you analyze multiple goals. How to difficult to obtain a single organizational goal. Important of goals may change over time. Goals and sub-goals are viewed differently. Goals changes. Dynamic of groups of decision makers, and then assessing importance of priorities. You can give points actually when you have assess priorities. You can do weighted. You can do weighted. You give weightage to certain points. For example, utility, you can give weighted. Utility goals are based on weightage. You do weightage average. Yeah, you do weightage average, and then we have another thing is called sensitivity analysis. Sensitivity analysis uh can be automated or trial and error. What is sensitivity analysis? Is I will not read the whole thing, but basically sensitivity analysis is you change the decision variables or goals or you change the goal setting, goal variables. So when you change, you can see the impact. We have a formula, for example. Remember, you have a formula. And then when you change the decision variable, you can see that there is changes in the decision in the result variable. Change the decision variable, the result variable will be changing. That is sensitivity analysis. So you look into you can make some assessing the impact of you can how if I increase the markup by 1%, what will be the impact of the profit? How many percentage will be increased in the profit? That is sensitivity analysis. Yeah. So whether you want to reduce variable or eliminate the variables, we change. For example, variable is your markup. Markup pricing, for example, cost plus pricing just now. Cost plus pricing is your cost plus your margin. You get your pricing. So if you change the markup by Instead of 10%, you increase the markup by 11%. What will be the decision? You have a formula, profit formula. Your profit formula will take into account your labor cost, your material cost, your fixed cost, yeah, variable cost, and so on. And then at the end, you will have your profit, gross profit, and then you minus your depreciation and so on, your amortization. You will get your net operating profit, yeah. And then, of course, before tax. And then, if you make certain changes, a small change, I would say 1% in your margin, cost plus pricing, your margin, your markup, what will be the effect at the end at your result variable? That is sensitivity analysis. Yeah. Is it clear, Ernest, Tasha?
Yeah.
Yeah. So that is how you work out. So you can revise the model so that you can make certain changes. So you can add details about the sensitive variables. You can estimate sensitive variables. You can say, okay, there might be certain a few variables that you play with. I don't have an exact example today, but say you have different variables. If you change this variable, what will be there? If you change this variable, what will be the result variable? So that is sensitivity analysis. So it can be automatic. You can, or you can just try and error. Automatic, you just use Excel, you just change, or you can try and error. Yeah. What if analysis? We have covered that. What if analysis is you provide solution based on changes in variables. Similar, but you say if you set up your decision variables, what will be the difference between sensitivity analysis and what if analysis is what if analysis you set up your decision variables. Sensitivity analysis is where you make changes, you varies your what if your decision variables. Yeah, you make changes. That is sensitivity analysis. You want to see how much impact will be on your decision on your result variable when you change your decision variables. That is sensitivity analysis. What if analysis is you set up your decision variables at a certain amount, and then what will be the amount that you will get at your result variable. Yeah, that is what if analysis. Goal seeking is a backward approach where you have your result variable first, and then you determine backward because the formula is there, whether it's net present value, discounted cash return, the ROI, or profit. The value is already there, and then this profit is not just revenue minus cost, because revenue is affected by when you get to your revenue, depends on your pricing. Yeah, so there is many variables in that components. And then you work backward. You have set your goal, and then you work backward so that you can determine your decision variables. Yeah. For example, break-even point determination. In order to have break-even point, how much do you need to sell for a month? Yeah, decision variables. For example, break-even point here. Break-even point is where your break-even point, BEP, is BEP. At your BEP, your fixed cost equals your total your contribution margin times unit produced. Yeah, so we work backward. Actually, because your profit is equals to revenue. Yeah, so you contribution margin, yeah, revenue or contribution margin minus times unit produced minus fixed cost. So when profit is zero, fixed cost equals contribution margin, right? Right, Ernest, James, when profit is zero, so you move this fixed cost is equals contribution margin. So you have this formula, break-even margin, which layer of fixed cost equals your contribution margin. Contribution margin comprised of your price minus your uh, unit to variable cost. Okay, so this is okay, and then this is what if analysis. Example in Excel, you have unit revenue, unit cost, initial sales, sales growth, and no profit. You can test this in your Excel. Goal seeking, where you work backward, you have investment problem. You need to find the interest rate. You find the interest rate where you have an investment amount here, and then you need to find the interest rate. You work backward. So okay, now we move into decision analysis with decision tables. Yeah, decision analysis with decision table. Decision table is a tabular. You have a tabular representation of decision situation. You have goal, you have yield. Yeah, goals. Example here, goal maximum. How do you maximize the yield after 1 year? Yield is this. What is the status of economy with the solid growth, stagnation, inflation? Yeah. This is decision tables. Yes, decision table you calculate based on payoff. If stagnation, the bond will yield 12%. If solid growth, the bond will yield 12%. The stock will 15%. Time deposit will be 6.5%. In stagnation, bonds will yield only 6%. Stocks will be at 3%. Time deposit 6.5%. If there is inflation, the bond will yield 3%. Stocks will lose 2%. Time deposit will yield 6.5%. So this is the formula here. You put into table. So bonds, stocks, yeah, and then the time deposit, yeah, certificate of deposit, yeah, solid growth, stagnation. So we have payoff, decision variable, uncontrollable variables, and result variables, projected yield. Yeah, so we have optimistic approach and pessimistic approach. Yeah, so this is the bond. Okay. Beside that, what is a payoff? What is payoff? Payoff is the thing that you will get in return. What will be the benefit that you get in return from your decision? Then you have decision tree. Decision tree is a graphical representation of relationship. Can be induced from data mining, can be expert driven. Expert driven is qualitative. This is quantitative. This is qualitative. For example, like qualitative, say you will have, if you have, if you decided, say, for example, if you are diabetic means that what is the qualitative factor of diabetic? Diabetic is when your uh, glucose level increase. Why does your glucose level increase? Because your pancreas does not produce enough insulin. Yeah, what is the purpose of the insulin? Insulin is to convert your glucose into glycogen, and then this glycogen will be kept at your muscles. So when you have diabetic, your pancreas does not function well, so it does not convert the transform the glucose to become so that is qualitative. So you may have physicians, doctors who put, so you have experts, knowledge driven. So you can have multi-criteria approach. We have graphs. We have graphs, decision tree. So you can demonstrate complex relationship. So these are many tools exist to use this. Yeah. So it's decision tree are trees actually. It's you have graph something like this. So you have it is like this. And then you have decision. Say this was one decision, then this was one decision. It is form of a tree. Yeah. So it is three. It's actually three. So we have so at the end of it, what will be your decision based on the leaf of the tree? There are branches of the tree. So this is so you can have a quantitative versus combined with qualitative decision. For example, in order to make decision for approving a loan, you can look into the amount of loan and then you compare, say, for example, the number of age, the age of the person is he working or not? He's not working. So you can read, so there is, and then if he's not working, is there any guarantor? Or is he have other source of income, for example, like that? No, any source of income. So it is a multi-criteria approach. Yes, something like that. Okay. Any questions so far? Okay, I'll just move on. Simulation is the appearance of reality. It's often used in what-if analysis. What-if analysis, and then you simulate. What-if analysis begins with, like we covered earlier, what-if analysis begins with decision variable. Don't get confused. Decision variables and result variables. One end is decision variables, the other end is result variables. Yeah, so decision variables, if you can decide on it. It is not the final decision, but you can decide on it. Okay. Decision variables. So it begins with decision variables, and then you put in the decision variables, and then it will simulate to produce the result variables. So it is a very popular decision support system techniques. So to conduct experiment computer so that you can change the what if. So you can simulate scenario 1, scenario 2, scenario 3. You can have many scenarios so that you can determine what will be the best decision based on your simulation or appearance of reality. Major characteristic of real simulation, it needs to imitate the reality, captures all richness of both shape and behavior. So it imitates, not represent, it imitates. And then you have technique to conduct the experiment, and then it is descriptive. Descriptive, meaning that it explains. It is more normative tools, and then it solves complex problems. So it will be used only when a numerical optimization is not possible. For example, you don't have linear models, mathematical models, so you use simulation. Advantages of simulation, the theory is fairly straightforward, great deal of time compression, experiment. I think you can read this. Also, it can handle wide variety of problems, include real complexity, produce performance measures, often used in decision support system modeling tools for unstructured problems. Disadvantage, it cannot guarantee optimal solution. It is not mathematical model. It is descriptive model. It's time demanding and costly construction process. Cannot transfer solution and inference to solve other problems. So it used expert models, expert models. So how do you develop your simulation methodology? First, you need to define the problem. I think beginning just now, we talk about the real world problem, and then you need to define the problem. You need to identify what is the problem instead of the symptom. You need to get what is the problem, construct the simulation model. In order to construct the simulation model, you need to know what are the variables, interplay of the variables, qualitative models. And then test and validate the model, design and conduct the experiment, evaluate the experiment result, and implement the result. And then when you implement the result, whether it changed the real world problem or not. If it doesn't change the real world problem, you iterate. And then you redefine the problem, you construct again the simulation model, test and validate the model, design to conduct the experiment, evaluate the experiment result again, and implement the result in the real world until you get an optimum solution. and then this is your decision to be made. Okay, so for and you can have stochastic or statistical or deterministic simulation. You use probabilistic distribution. You can have time dependent or time independent simulation, or you can use Monte Carlo simulation. The Monte Carlo simulation is where you put in random. It is a situation where you have no certainty, we have about uncertainty, you have no knowledge, and then you put in random. So you have all your probabilities distribution is based on random. Yeah. And then you can discrete event, or you can have continuous simulation, or you can have agent-based simulation. So the simulation can also be visual or object-oriented simulation. So this is visual interactive simulation. To address conventional simulation modeling, you use computer graphic and animation. You can integrate with radio frequency identification and geographical information system. So you can simulate and you can interact with it, and you can see sensitivity analysis. You can have virtual reality, immersive presence. This is virtual interactive simulation. When you change certain model, you can see the figure change. It depends on the area, maybe medical, maybe modeling products for marketing and so on. So this is simulation software. You can just visit the site and look into how they use just simulation. Yeah, you can given there. Okay, we have covered the topic of optimization and simulation. Okay, I need to stop share first. Next topic will be topic 7. Topic 7 will be on topic 7 will be on decision making, still on decision making, and then we will look into how do you formulate your problem. You look into how do you formulate your problem, how do you make decision analysis without probabilities, and then how do you make decisions with probabilities, and then how do you make decisions with sample information, and then how do you make informed decision based on Bayes' theorem, and then we will also cover utility theory. At the end, we'll cover utility theory. Okay, any questions so far for this topic before we move on to the next topic? Any question?
Doctor, can we have a break?
Okay, we'll take a break of 15 minutes. We can come back at 3:50. Yeah, 15 minutes, 10, 15. We come back at 3:50?
Okay, thank you.
Okay, thanks. Okay, we will continue short while on chapter 7. Chapter 7, we will look into decision making. The topic is decision analysis. So as we have gone through many classes even just now. The business analytics is about making better decisions. So decision analysis is how we can use them to make optimal decision, optimal strategy. So when decision maker face with several decision alternatives or an uncertain or risk-filled pattern. So we say just now there are three types of decision you can make based on certainty, where there are things for certain, you can use decision analysis, decision tree, and so on to make decisions. Or where are things uncertain, nothing that you knew. Or we have things which are or there are things that are we have information about probability. Yeah. So good decision analysis will include careful consideration about all these factors. So we look into risk analysis. Risk analysis provide probability information about whether it is favorable or unfavorable outcome. We call it payoff. Payoff is how much will it pay to us. The result. Decision analysis will consider problems involve reasonable few decision alternative. Remember, we have decision alternative and reasonably future possible future events and uncontrollable variables. And then we look into what is the result variables or payoff tables, decision tree, sensitivity analysis, or we can use, we covered sensitivity analysis. Now we will also cover Bayes theorem. So how do we formulate our problem? Well, the first step in decision analysis problem is to formulate the problem. We start with creating a verbal statement of the problem. You identify the decision alternative, what kind of decision there are. And then remember, we have covered this in our MIS. How do we make decision? Make decision based on you need to, we call it, we identify the problem. Yeah. Once we have identified the problem, we look into solution, we enter into alternative solution. And then from this alternative solution, each alternative solution will bear certain risk, a certain payoff. Clear. Okay. First, we need to identify the problem. Okay. Once we have identified the problem, the next step is to look into solution alternative. More solution alternatives will be alternative 1, alternative 2, alternative 3, and each alternative will have their payoff. Alternative 1, say alternative 2, alternative 3, alternative 4, alternative 5. See. So each alternative will have, for example, we have for each alternative set, there will be, say, there will be, say, cost, there will involve some cost, we'll have some revenue, say, and then will be, say, revenue, what do we revenue? Revenue, this is just an example, revenue cost. Depends on the area you research, maybe marketing or HR, so on. So this is profitability accounting, say, revenue cost, and then you can get your contribution margin. And then at the end will be your gross profit or GOP, gross operating profit, or net operating profit, and so on. So this will be decision alternatives. You look into the payoff, total payoff of each of these alternatives, and then you will pick the best solution. Might be in terms of revenue, might be the solution have the largest amount of revenue, but it might not be the best amount of profit. You look into the final decision, and then you will select this alternative, and then involve, we call it selection of selecting of, what do you call it? Choosing the decision. Yeah. Choosing decision alternative from alternative. And then you will implement that. Implement. From the implement, you will get feedback, measure feedback, measure the result. Yeah? Result of your decision. And then you will go back to identify problem. Yeah. Then it will be a circular. Yeah. Okay, this is how do you make decision? Yeah. So you first step is create a verbal statement and then identify the decision alternative. For uncertain future event, you look into chance events with probability of the certain event occur. And then the outcome associated with each combination of decision and chance, decision alternative and chance event outcome. Meaning that you look into alternatives just now. They show to you whiteboard. Yeah, you measure each alternative. Yeah, each alternative. What will be the outcome, and then you choose the decision based on the optimum solution, best solution that you want to have. Yeah. Yeah. Then you will implement them, and then you measure the outcome, and then this is iterative. The term is iterative. Yeah, this is iterative. It's circular. Okay. So example here. This is an example here given. Facebook Development Corporation. Okay, this is from the book CAM. From CAM Development, from the book from CAM, call it Business Analytics, CAM Cochrane. So the example given here. Pittsburgh Development Corporation commissioned preliminary architectural drawing for 3 different projects. They have 3 different projects, 3 options. Whether they want to do one project with 30 condominiums, which is a small project, or they want to have a mid-scale project, one project with 60 condominiums, or they have a larger scale project, which is one project with 90 condominiums, a large scale project. So the financial success of this project will depend on the size of the condominium complex. It could be 30, 60, or 90 condominium. And then chance event concerning the demand of the condominium. So there can be high demand, low demand, or mid-scale demand for the condominium complex. So the PDC, the Pittsburgh Development Corporation, need to select the size of the new luxury condominium project that will lead to the largest profit. What will be the largest profit given the uncertainty concerning the demand? The demand is uncertain. So based on that, given the statement, it is clear that decision is to select the best size of the condominium project, given the alternative, which will be alternative decision one. Decision one is to have a small complex with 30 condominium. Decision 2, which is a medium complex with 60 condominium, or D3 to have a large scale complex with 90 condominium. So in order to make the decision analysis will conducted. The possible outcome for the chance events are the states of the nature. So states of nature are defined as mutually exclusive and collectively exclusive, meaning that it is no more than one can occur, cannot be more than one occur, meaning that there will be only one decision, and then collective exhaustive, at least one must occur. They have to change. They have to decide whether they want to have D1, decision 1, decision 2, or decision 3. So only one possible state will occur. So PDC will only select one. The chances will be two chances, states of nature, we call it states of nature, two chances, which is chance event, which is strong demand and weak demand. State of nature 1 will be a strong demand for the condominium. State of nature 2 will be weak demand for the condominium. So we do a payoff table. Payoff table is you look into you look at the outcome, and then what will be the payoff, what will be the gain gathered by obtained by the company, yeah, when they make certain decision. If they decide to have, so they have decision alternatives here, small complex D1, medium complex D2, and large complex D3. If they make small demand, small complex, they make small decision, yeah, small complex decision alternative 1. If there is strong demand, they will make 8 million worth 8 million return. You make 8 million return. Small complex, the return will be small, 8 million return if there is strong demand. But if there is weak demand, they can still make 7 million return, because it is a small complex, might be that the cost is not that high. So if there is a weak demand, they can still make 7 million demand. So because small complex is about 30, it's mentioned that it is about 30 condominiums. Yeah, if it is a medium complex, this is decision alternative 2 with strong demand, because it is a 60 units of condominium, they can make 40 million profit. Yeah, 14 million profit. If it is a weak demand, they will make 5 million profit, because they have spent on 60 units of condominium. And then with weak demand, they might not be able to sell all, so they only make 5 million. For large complex, they will produce 90 condominiums. With 90 condominiums with strong demand, they will make 20 million profit. At weak demand, because the cost of developing 90 units of condominium is high, they will lose 9 million. So this is the payoff, the outcome result from specific combination between the decision alternative, whether to produce 30, 60, or 90 condominiums, and with the demands, whether there are strong demands or weak demands, and then the payoff shown here, how much profit it will make. Yeah. So we will use notation Vij to denote the payoff associated with the decision. So with decision, with I is the amount of decision, the number of decision. V3 is decision alternative 3, which is to produce to produce 90 condominium, 20 million, 90 condominium, and with strong demand. Yeah, strong demand. So we give a payoff of 20 million. So you can see here D, I, and J. Yeah, so you can build a decision tree. Decision tree is a graphical representation of the decision. It shows the natural or logical progression. Yeah, so this is the decision tree. So with small demand, small project of 30 condominium, with strong demand 8, weak demand 7, medium 60 condominium, strong demand for 40 million, weak demand 5 million, large demand will be 90. Large project will be 90 condominium, strong demand 20, weak demand, they will lose 9 million. This is the decision tree. Yeah, so if we are required to develop a decision tree, This is a decision tree. Okay. So we use node to represent the decision and the node and chance events. So square nodes is to depict the decision node, and skulls are the event nodes, the chance nodes. Yeah. So you can essentially this is up to you. You can just change. Okay, branches connect the nodes leaving the decision, and then branches leaving the decision node. The branches node leave this decision node to the decision alternative, and then branch leaving the chance node correspond to the states of nature. So at the end, we have this is the graph. Okay, now decision analysis without probabilistic. Okay, in which a simple best case and worst case analysis is sufficient. But okay, decision analysis without probabilities is looking into what is the simple best case and worst case analysis. Yeah, so you just want to look into best case, simple best case, and worst case analysis. So decision has little confidence of to assess. Uh, when do you do this? Is when you have no probability information or you have little confidence to assess the probabilities. So the optimistic model evaluates each decision alternative in terms of the best payoff. So it is recommended the one that provides the best possible payoff. Yeah. So minimization model look into the choosing the alternative with the smallest payoff. What is the best possible payoff here? In PDC, in the case just now, the maximum payoff is 20 million. Maximum payoff, 20 million payoff, which is the large complex. They make decision 3, which is the 90 condominium. Okay. Now, the question is, what is the alternative, the best alternative with the smallest payoff? The best alternative, okay, this is the question. The conservative approach evaluates each decision alternative in terms of worst payoff. The decision alternative recommend the one that provide the best of the worst possible payoff. Okay, in this case, what is the best of the worst possible payoff? Best of the worst possible payoff. If there is a weak demand, for the condominium, when there is weak demand of the condominium, what is the best possible payoff? Anybody?
30,
If there is a weak demand,
30 condominiums.
30 condominiums. When you make 30 condominiums, when there is a weak demand, you can still make 7 million. So your recommendation to your board will be, if we suspect that there will be a strong demand, we should do a large complex where we can have, with strong demand, we can have a margin of, or return of, or we call it payoff of 20 million. We will build 90 condominium with, but if there is weak demand, we should just opt for a small complex of 30 condominium. We still make 7 million. Instead of the medium, if you go for medium, the week is only 5. Yeah. So this is the thing that you need to look at. This is without probabilities. Without probabilities, when do you do without probabilities? Is when there is when you want to have a simple best case, worst case analysis. You just want to look at what is the best case, what is the worst case analysis. You just want, because your management might ask you, what is the best case? And then what is the worst case? Okay, in the best case, you can make 20 million, but you produce 90 condominium. Best case. But the situation must be there is strong demand. Okay, the worst case, if there is weak demand, what would be the best case? The best case for the weak demand is to do a 30 condominium. You can still make, how much was it? 8 million, right? million just now, right?
7.
7 million. You can still make 7 million. So this is decision making without probabilities. Without probabilities. When do you do this? Where you have little confidence in to access the in the probabilities. Okay, so you just look into this. Okay, when you can access the probabilities, okay, the regret is the difference between payoff associated with a particular decision alternative and payoff associated with the most desirable payoff. Yeah, so it is opportunity loss. For example, between decision, say we can say if I make decision to opt for say medium, you say what will be comparing the medium. So you look into the minimax regret is the minimum and the maximum regret, yeah, for this situation. So you just calculate the difference between the maximum, the payoff is with the best decision, and then the payoff to the decision alternative. Yeah, you just calculate that. So if there is weak demand, for example, it would be small complex, be 12, 0, 6, 12, and 0, 16. So this is just calculated the difference between the two. Yeah. Okay. Now the for small complex, the minimum of the maximum regret is 6. Yeah. Okay, now we look into decision analysis with probabilities. When you decision analysis with probabilities, you calculate what we call the expected value approach. We calculate expected value. So we use an approach called expected value approach. Expected value approach is we count the probability. There's a probability here, P. Yeah, as J probability. Based on Bij, then we do an expected value approach. So the chances, so this is probability is given. Usually in case study, probability is given, but in real study, you have to check. How do you calculate? How do you obtain the probability usually? How do you obtain the probability? Anybody? In real situation, in case study, usually the probability will be given. But in real situation, how do you obtain the probability? Real situation. Yeah, Tasha? In real situation. This is case study. Case study, usually the probability is given. But in real situation, how do you get the probability? How do we obtain probability? In say you are in the actual field work. Yeah, Tasha. Any idea, Tasha?
No.
Ernest?
By intuition. I'm kidding.
Yeah.
By intuition.
By
intuition. I'm just kidding. I think it's based on like past data and trends.
Yes. It's based on past data and trend. So you know, from the analysis, you can do social or PESEL or some analysis, and then you can expect what will be the demand. Say you want to build a condominium in certain places, what will be the demand, how many people are living there, what are the attractions to go there, and then you can estimate the demand based on past trends. Yeah, so we have past trends, how many people buy houses there, and then is there needs for condominium. So based on past trends, you can estimate the probability. Okay, this is the probability given. Probability for strong demand is 0.8. Probability for weak demand is 0.2. Yes, S1, probability for S1 is 0.8. Probability for S2 is the state of nature is 0.2. Yeah, strong demand 0.8. So the chances are there will be strong demand. So they will calculate. The formula is to calculate, to multiply the probability times the value, the payoff. Yeah, the payoff multiple. So you have an expected value approach, they'll multiply the value. Yes, 0.8. So for expected value for decision alternative 1 is to, which is to build 30 condominium, will be 0.8. This is weighted. Yes, the method is just like you do any weighted. You multiply by 0.8, which is the probability of strong demand, times 8 plus probability of weak demand plus 7 times 7, you get 7.8. This medium is 12.2, large value is 14.2. Yeah. So expected value for payoff is probability of associated state of nature, and therefore the probability that the payoff will occur. So you multiply. In practice, we use historical data. Yeah, like I mentioned just now, historical data is being used. Yeah, this to use for estimating the probability for different states of nature. So historical data, you look into past trends, historical data, so you can have the probability, so you can measure the expected value. Excuse me. Okay. Any questions so far? Tasha, okay, Tasha? In real life, actually, you look into
Yeah,
past record. Yeah, past record. So you can gather some data, get the past records, and then from there, the chances, you can know what will be the chances at certain time there will be strong demand or weak demand, or whatever the situation you are involved, whatever cases you will be handling, it will be based on the historical data. Yeah. And then we will look into risk analysis. Risk analysis help decision maker to recognize the difference between expected value and payoff that may occur. So you can have risk profile. Yeah? So this is the risk profile. And then sensitivity analysis, we have covered sensitivity analysis. How changes in probability. So same thing, but you change the probability. If there is changes in probability, for example, from strong demand, and then you move into weak. If it's change from strong demand to weak, and then what will happen? Yeah, so you change from 0.2 probability for weak demand is 0.8. If you change instead of 0.8, which is the strong demand, you change it to 0.2, and then weak demand 0.8. So you change. So this is the chances. So you sensitivity analysis, so the expected value will change. So that is decision analysis. And sensitivity analysis is changing any variable. Now you change the variable for the, instead of earlier, we talked about the changing the variable for the price, we change the variable for the demand. Demand is also a variable, so you change the variable for the demand. Okay, the demand probability. Yeah, so decision example analysis with sample information. We have this is an example. If you have sample information, we look into how do you use the ability to collect additional information about states of nature. We can use we can obtain it through experiment. Get sample information, so you can go sample, you can test with certain example, and then you calculate the prior probability and posterior probability. This is prior probability assessment before your assessment, yeah, state of nature. And then after obtaining the information, you have you revise the probability. We call it posterior probability. So have prior probability and posterior probability. So you need to have a decision strategy in sequence of the decision, and then you look into outcome. So based on yet to determine chance events. So this is decision tree. When there is a favorable report, there is a non-favorable report, there is no market study. It's about the same thing, but and then you multiply based on the 0.94, 0.06, based on the posterior survey. Yeah. Yeah. After expected value of chance, you have this. Yeah. Okay. It's just formula. Yeah. Best decision, you need to make, in order to make best decision with the favorable report, you have 18.26 expected value, unfavorable report 8.25, 8.15, and when there is no market research, it will be 14.2. Okay, and then you will do reduce it to decision. When there is market research, 15.93. Without market research, the expected value is 14.2. Okay. If the market research is favorable, construct the large condominium complex. If the market research is unfavorable, construct the medium condominium complex. Yes, because the medium condominium complex has greater medium condominium complex. Yeah. Number 3. Decision 2. Okay, value of sample information. This is using, just now we use probabilistic. We do a survey, get sample information. This is the difference of sample information. And then when we have expected value of sample information, with sample information, and then without sample information, the difference. This is the difference between expected value of sample information. And then when we have what is the expected value of perfect information? We have perfect information about the states of nature, whether D3, or whether S1 or S2. State of nature S1 is when there is a good demand, strong demand. S2 where there is weak demand. So what is the payoff? 20 million and 7 million. This is when you have available perfect information. Yeah, when you have available perfect information. So this is available perfect information. Same formula. This is absolute. Yeah? Absolute. This is calculation method. Now any question? Okay, we move into Bayes' theorem. What is Bayes' theorem? Bayes' theorem is a probability theorem where certain situation is conditional on a certain probabilities. The certain occurrence is the probability of A happen when B has happened, or the other way around. Probability of B happen as if A has occurred. Yeah, so to compute a branch probability for decision tree, so conditional probability, meaning that the probability of S is given that S2 has happened, something. Yeah. So S1 is given that F has happened. Yeah. Favorable market report. And then S2 happened with a favorable market report. With a favorable market report, what will be the strong demand? If of unfavorable market report, what will it? So the situation is a conditional probability. A favorable market report, market research report, or unfavorable market research report when there is a strong demand and when there is weak demand. Meaning that what is the probability of a strong demand when a favorable report have happened? What is probability of a strong demand if unfavorable report has happened? Meaning that this probability is conditional to the favorable report. Meaning when there is favorable report, and then people will start buying. Then we will start buying, there will be an increased demand. They will increase demand. Or there is an unfavorable report, what will make people start buying? And so this is the subject to Bayes' theorem is based on conditional, meaning that what is the probability of A when B has occurred, or the other way around, or what is the of B if A has happened. So this is in case of this favorable report has happened, and then what will be the demand? Strong demand or weak demand? What is the probability of strong demand and weak demand? So this is a given formula for, actually this is Bayes' theorem. Any way you look at it, it's similar. Probability of AI happening when B has opened, B has happened is probability AI and then times probability of B over AI. B has opened, happened. And then where probability of AI, A1 times probability of B and A1 plus until we have probability A to N. This is the number of events. Yeah, it can be events, 2 events, 3 events. This is probability that we have learned. Conditional probability, Bayes' theorem. Okay. I think if you can look back into Bayes' theorem, but this is the formula given here. You can read, but this is things that we learned in our statistical class. Yeah, statistical class long time ago. So probability of A happen when conditional of probability B has happened. Yeah, subject to B has happened. So this is the way we calculate it. And then utility theory. Okay, any question before we move into utility theory? Okay, utility theory is about, sometimes when we make decisions, we don't just look at monetary value or financial gain or financial return. Payoff is not just at the financial return. We look into other factors like quality of life, something like that. So sustainability, the ecology, keeping the ecology. For example, we don't use plastic not because it's less with profit. We don't use we don't use plastic because we want to conserve the world, conserve the ecology. We want to protect the earth, something. So we look into the utility, and then we give a figure, a measure of total worth. We give a figure for the utility. Even for the monetary value, it is not based on the monetary return. We give a figure, we give a token. Yeah. So we give a token for the return. Yeah. So decision 1, whether we want to make this investment in A, decision 2, investment in B, or do not invest. So this is the real estate go up, the states of nature, the real estate price will remain stable, or the real estate price will go down. And then when you look into utility, you can look into other monetary value, what's happening to this. Best payoff or worst payoff. So we develop the identify value for each utility. We give figures. We give the amount of value to. So you calculate the probability and then you give amount of value of the utility, expected utility. Convert even the monetary value, we convert to a utility. What is the utility if we make a certain amount of profit? What is the utility of making a lesser amount of profit? You give a token of value for the utility. What is the amount if you are able to save certain population of certain birds, or what is the amount if you reduce the number of trees being cut down, for example. So you give utility. So you same formula, but instead of the expected value, we use expected utility. Expected utility, same formula, probability. Yeah, this is probability times the utility instead of the value. Instead of the value, we convert it to utility. It's the same figure, same way how to do it. And then but you look into the utility value. Utility is based on a token given. You give a token. You give an expected utility. You give a utility value. Even for the monetary, we don't count based on the number of value, but you can tier them so you can give a utility value. Yeah, utility function. Yeah, so this is the utility function for money for this avoider, risk taker, and this neutral decision makers. Yeah. Okay. Then this is exponential utility function. Yeah, so you can calculate that. Okay, that is utility value. Any question on utility?
Prof,
Yes.
are these notes in the textbook?
Yes. No, this is not in the textbook. This part is not in the textbook. This is not in the textbook. This is additional. This is in the book. And if you can get this book, I'll try to get as a copy. This is just a chapter in this book, Business Analytics. Yeah, from Cam Cochrane. Okay. Okay. Can we take a break? Because after this, I want to do some just run through of R. Just run through of R. We just play around with R. I'll use my R software and then just run some programming together, and then how do you can assign value operators, just and then yeah, we can just there is no specific notes, but we just play around with bolts and nuts I've given to you on the R. So any questions so far? Any question so far?
No, doctor.
No, yeah, okay. Can we take a break of 15 minutes? Take a break of 15 minutes. Now I assume 3:30, 4:35. We come at 4:50.
Okay.
Okay. Okay. Okay. Is everyone back? Is everyone back? Ernest, Tasha, James.
Yes, doctor, I'm back. Yeah.
Okay.
So we
Okay,
open our studio. Yeah.
yes, you open R Studio or R. R the R model, the R anyone, both can, yeah. So I hope everyone is open. You can either open up the R software at the CRAN or the any R environment or the R Studio. I'm opening an R Studio, but you can also use the R CRAN at CRAN. So I'll open up R CRAN. So this is our studio. Everybody has opened it. Let's see. I think I'll just open the other R. Show you the other R. So that is much. Just use the other R. But you can also use the R CRAN. Both R you can use. I couldn't find my R. Okay, I'll just open my R Studio. Difficult. Okay, share my screen. I didn't open it just now, so I couldn't find it. Okay, this is R. Okay, there is 4 portions here. This is the environment, this is the files, this is the console, this is the terminal. Okay, but you can just use, if you open up the R at the terminal CRAN, you just will only see this. So did that print hello world just now. You can R comprised of they have data types. There are data types comprised of vectors. You can do vectors, you can do matrix, you can put list, you can put array, data frame, or can you put factors. Now we will start vector. So before you start vector, usually the trend of any computing programming, you will start print hello world. Just start here, just print bracket hello world. When you enter, it will print hello world. Instead of this, you can give this variable. You can create this variable. You can create a variable. How do you create variable? Is we can create a hello string variable. This is the variable, and then you give a sign. Yeah, assign this variable with a string. Yeah, this is a assignment. So okay, this is assignment, and then you can give it a string. Say hello world. Okay, and then this is, you have assigned a string. You can see here on the environment hello string. Yeah, on right hand side, hello string. There's the variable is, this hello string is a variable. The value is hello world, and then when you ask the print, print, no, I have to put here print. You ask the print, say hello string, yeah, enter, will print hello world. Yeah, this is hello world. Okay. So you can also save this as create. We will, for now we will not do create the script yet, but we'll look into vector. We will start vector like mentioned just now. Hello comprise of, okay, you can have multiple. Among the data types that you can use for hello is vectors, matrices, lists, arrays, data frames, and factors. We will start with vector. So vector, how do you create a vector? Okay, when you do when you do any programming, anything that you put with hash, it will not hash. When you do with hash, it will not do anything. So say you want to create a vector, it will not act on it. So create the vector, nothing happen. You can see the environment, nothing happen. We'll create a vector. So we will create a vector called student. We'll give the vector student. How do you provide? You will start with C, and then you put the vector in. Say you can say vector comes in, say we put in your name, say we have, this is the names that I see in front of my list. Tasha, then say comma. These are strings, yeah. Tasha, say we have Ernest, then we have James, yeah, strings. Yeah. And then enter. Okay, see, side here, and the environment, you can see there is a variable called vector. Variable called vector. It is a character, 248 bytes. The character, there is 1, 2, 3 characters, meaning they start with 1, 2, and 3. Meaning there is begins with 1 character. This is called the index of the character. The index number 1 is Tasha. Index number 2 is Ernest. Then index number 3 is James. So now we will check what is the class of this vector. What is the class of this vector? So we want to say, so first we want to print. We want to print what is student. Student is a vector just now. You see here, student is a vector. We print student. Print student. Say the student is Tasha, Ernest, and James. This is a vector. This is an array. Yeah, Ernest, Tasha, Ernest, and James. Now we want to see what is the class of this vector student. What is the class? Print. Yeah, so we have class. What is the class for the vector student? Okay, student. Class, it is a character. Okay, say I want to print student. I type print int instead of s. I put student. Error. Why is it error? Because variables are case sensitive. Variables are case sensitive. So when you say print, when I type student in small letters, object, oh no, because I put here plural s. Yeah, this is plural s. So you need to be exact, and it is case sensitive. Print student. Then only you get back Tasha, Ernest, and James. Okay. So we ask whether the vector is okay. Now we have learned vector. This is a character of vector. Now we create another vector. We create another vector. VCPOR. Create another vector. We give vector 1. Now this is another vector. Vector 1. We give 2. So we assign to vector 1. We put some numbers. Say 1. Okay, when you just now we put close and open inverted commas, it becomes character. So when you want to put into string, we don't into numbers, numerical, we don't put the inverted commas. We just put 1, say 2, 5, 3, say 6. Say you want to put some minus 2 and 4. Yeah. So this is a vector. So and then you create another vector. Say vector 2. Vector 2. We give this a logical vector. Logical vector. Yeah, logical vector. You can say what is the logical vector? We give C. Yeah. You create a create a vector. We use C, and then you say true. Say true. False. True. Say false. So this is a logical vector. A logical vector. Now we want to print vector 1. Print. Say vector 1. Print vector 1, we will have 1, 2, 3. 1, 2, 5, 3, 6 minus 2, 4. Say we want to print vector 2. When we want to print vector 2, we will have true, true, false, true, false. Yeah. Okay. Now we want to get information from the vector. We want to get information. We see we have already 2 vectors. Can you see here? Vector 1 is number 1 to 7. Index, this is index 1 to 7. Yeah, on the right hand corner here. Logical, we have 1 to 5. This is 1 to 5. Yeah, so they have index 1 to 7, 1 to 5. This is 1, 2, 3, 4, 5, 6, 7. Yeah, 1 to 7. Now we want to call vector number 2 and 4. Say you want to call number 2 and 4. We print. This is how we retrieve. Very easy. Instead of learning SQL, R is easy. You just want to recall vector from vector 1, print from vector 1, 1. So you put the square bracket here. Yes, square bracket here. And then you want C. And then you want to get 2 and 4. 2 and 4. Yeah, so print vector 1. From vector 1, you want to get the index number 2 and 4. What do you get? You get 2 and 3. See, 1, 2, 3, 4. Yeah, index number 1 is 1. Index number 2 is 2. So you get 2 there. And then index number 3 is 5. Index number 4 is 3. So we are calling for number 2 and 4. So you get 2 and 3 here. Yeah. So okay, then we want to create, how do we can also create another vector, and then by just put by creating a consecutive numbers. Yeah, say you want to continue consecutive numbers. You say we create vector, then we give 1 colon 8. Yeah, 1 colon 8, and then we want to call this vector V. Enter. So you have 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Or you can also use create vector moving from minus to positive. You can have vector, yeah, minus. You can this assign 2 to minus 2. Yeah, 2 to minus 2. And then you call the vector V, called V. V. So you have 2, 1, 0, minus 1, minus 2 here. Okay, say, now you want to print V again. Yes, just print. Okay, we have 2V here. V here is 1 to 8. 1, 2, 3, 4, 5, 6. Then you have another V. 2, 1, 0, minus 1, minus 2. You just start print. V, what do you get? You just get the earlier one. The latest one. You just get the latest one because it have overridden the earlier V because you give them the same variable number. This variable. You can see the variable the V. Yeah. Say you want to put back the earlier variables, you put V. Yeah. Yeah. Put 1, 8. 1 to 8. Call variable. Okay. And second, you can see here V here on the right hand corner. The variable have been changed here. Okay. Okay, if you want to change to use a more complex variable, yeah, you can type you can create a sequence. Yeah, I think we don't cover a sequence yet. Okay, so far any does everyone do everyone follows me? Ernest, Tasha, James, who else? And Jack.
No.
Yes, a bit lah, a bit.
A bit. Okay, which one you you got lost? Which part have you got lost, Jack? Or Tan Week One, which part you got lost? Anybody?
Not sure why. I think just now halfway after a few steps, my owl suddenly cannot input the items anymore. So I have to restart again. I don't know. Yeah.
Okay. Okay. Anybody else? Tasha, are you following, Tasha?
No.
No, I'm talking alone. Okay. James, are you following, James?
Can, doctor. I just follow the command you put in the screen. I just follow, so I do the same now.
Okay. Say now, okay. What we have done to so far, yeah. Okay. How it works actually? We assign a variable. We assign a variable. Yeah? So here we create a variable. You can see in line. Student, for example, student. Yeah, student. We create a variable. This part, yeah, student. Can see, okay, can see this. You put into at the console, at the console here, prints which part? Okay, this line. Student, create a vector. This is a variable. Student is a variable, is a vector. So I give the student in the variable 3 arrays, a set of 3 arrays. An array of 3 data, an array of 3 data. Data Tasha, data Ernest, and James. Okay. When I key in here, you can see on this side, this is the environment student, the character, it is a character 1, 2, 3, meaning that is index 1, index 2, index 3. Say now I want to call student print student 2. Yeah, I call print. I want to print student 2. Student. Yeah, I put in square bracket. Number C. I put inside C, I want to put 2. Print student number 2. So you look at the data, print student number 2, it will give Ernest. Because Tasha is student number 1, Ernest is student number 2. This is called index. So if I want to call print student, you just can move up the arrow. You can see the in your keyboard, you have an arrow. You can just put up the arrow. Yeah, you can get back the old formula, the old codes that you put in. Yeah, print student. Yeah, now I want to change the student 1. Yeah, Tasha, student 1. So you can see this is the student. This is okay. This we have so far we have worked with 5 variables. Hello string, variable student, variable v, variable vector 1, variable vector 2. Variable, this is a string, variable 2, student, is a character. There are 3 data, index number 1, 2, 3, and then variable number 3 is an integer, integer, variable from 1 to 6, and 1 to 8, and then this is numerical, 1 to, okay, -2, 4, because this is numerical, and then logic. Okay, the variables. Thing so far. Okay, now you just follow what I've done here. Just follow. And then here I point out that it is case sensitive as student. This is plural, this is capital. So in case sensitive, when you call, you cannot retrieve them. This is singular plural, you cannot change it into plural. Still, you cannot change them. But when it must be exact. Yeah. Okay. We can also call back vector 2, for example. I can say print back vector 2 and vector 2. Say C number 2 or C number 3. So it is false here. 1, 2, 3. It is easier than SQL. So you just call. You just follow here. Slowly. I think next week we will meet in class, right? So we'll go again. We'll do again. We'll move to another topic, another task to do. Say we want to change. We want to change. We have vector here. You can see the variables here. V vector 1, 2, 3. Say this number 5. We want to change. So we put say vector 2, vector 1, vector 1, 1, vector 1, and then put in square bracket vector 1. We want to change 1, 2, 3. Number 3. Yeah, index number 3, vector 1, index number 3. You want to give it a value of 1, 2, 3. Say you want to put 0 there. You want to put 0. Yeah. So, and then we call vector 1. So 1, 2, you can see here. So just now it was 5, 1, 2, 5. It now become 1, 2, 0. Now we want to say we want to change it back to 5. See, you can see here 1, 2, 0, 3, 6, -2, 4. Okay, we want to change the vector 1, yeah, and then this numerical. You want to change the number 3 again back to 5. See, this so vector 1, 3 again back to 5. So change here 3 back to 5. You can put whatever number, change, then become 1 to 5. Here, 1 to 5. or you want to change the vector number 4, the index number 4, the third vector number 1, index number 4, you want to change to, say, -3. So just change vector number 4 here, 4 here, index number. You want to give figure 3, you want to give 0, say, to give 0. Okay. Now, 1, 2, 5, 0, 6, -2, 4. So you can change the index, the array, and the data in the array. Okay, everybody can still follow? James?
Yes, can, Doctor.
Yeah, can Jack, Sofina, Balkis, can you follow, Balkis? Never mind.
Yes.
Yeah, can because this is recorded. I'm record. I think I record this, so you can just look. I will upload this later. You can just follow. Okay. Now we want to move. Say you want to create a matrix. So remember, when you put hash code, it doesn't change any value in the environment. It doesn't change any data. It doesn't make anything. So when you create a matrix, say I want to create a matrix now. Remember, we learned in school matrix. We'll say, how do you create matrix? Say we give M. M is a matrix. Okay. M is a matrix. And then this matrix, say we have, what are the components of matrix? We have C, we put C, we start with C. Say, we'll give a space here to give some, so you can more clear, see clearer. So we have, we don't want to put into numbers, we put X. Say we have X again. See, we have Y. Let's see, Z, Y, and then ZX. Okay. Always overthird X, X, Y, Z, Y, X. Yeah. So this is a matrix, and then number of row. What is the number of row? Number of row is 2. And then you give them a number of column. Number of columns, say 3. And then we want to sort it by row. We want to sort it by row. So when we sort it by row, say by row. It's always by row. By row, you put through. So will be sorted by row through. Then, so you close. Then you enter. No, there is a miscalculation. Unexpected error. Additional comma here. Comma and row. Comma and column. By rows too.
The close bracket, Doctor.
There is a close bracket.
We have 3 close brackets and only 2 open.
3 close bracket, 2 open. There is another close bracket. A matrix C close bracket. Okay, this one C. This one C. Okay, 3 close bracket. This one there is no bracket here. See that one bracket. Okay. Now we want to print M. We can just move. Yeah, just print M. So M is sorted. This is by row, meaning that we give here X, X, Y, Z, Y, X, 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 Y, Z, Y, X by row. Yeah. Or you can just calculate, you can just set up another matrix. Say another matrix, you just give them 1 to 12. Yeah. And then you want to put another number of row is equal to 14, is equal to 4, and then number of column 3. So 12, 3, 4 by 3. Number of columns equals to 3. Okay. Enter. So we generated another column, another matrix. This is the row. This is the column, row by column. So this is so far. You just follow this first. Okay, everybody can follow. James, okay, James? James is following.
I'm not. I can't make out the end row and the end column, Doctor. A bit confused.
Okay, row. This is the number of row. There is 1, 2, 3, 4 rows.
4 rows. Okay.
Column 3. 1, 2, 3. You can see the comma here. 1, comma. This is empty because the comma, the column is here. So 1, comma 1 is 1. 2, comma 2 is 6, for example. So this is the row. This is the column. I'm not sure whether you can see or not, because I have to use the mouse. Okay. Can you see? Yes.
Yes. I can see it.
Yeah. Number column is 3. So here, when you put here, number of row is 2, row is 1 and 2. Number of column is 3. This is sorted by row. But when you just say column, it will automatically sorted by when you say call it by row, it will sort by row. Otherwise, when you give 1 to 12, it will be sorted by column. Say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It will be sorted by column. If you want to call it to ask them to sort it by row, you have to put it by row through. And then it will sort it by through, by row. Yeah.
In the case of the X, right?
Yes.
Why is it moving right ways? X, X, Y, Z, Y, X.
Okay, because we sort it by row. By row.
Okay.
If you don't tell it to sort by row, it will sort by column.
Okay, understood.
Okay. What about other students? Are you okay? Okay. Okay, you can also create matrix by giving dimension. By giving dimension. Say we give X. Say X. We will do a lot of matrix actually. For your information, when you do simultaneous equation or linear programming just now, you can use we can process it using matrix. Y, this become Y, this become X, and so on, and this the other one becomes Z. So then you can do simultaneous equation, but I'll show you later. But now we want to use the We want to give X. We want to create X a matrix. You create matrix C. You can set 1, 3, say 6, 4, 5, 0. Say we can get this is C, and then we dimension, or we can see, and then we dimension X. We give X plus C 2, 3. Special symbol in X. In X. Okay. No, this one. Dimension X. Okay. Comma. Yeah, so your dimension X. Okay, you can see X here. 1, 2, 2, 3. So, and then you call X. Okay, I'll show you. I need to move this inside. Okay, now you call X. You call X. X become 1, 2, 3. This is 2 by 3, meaning these two rows, 3 dimension. Yeah. So just now I made it. So we give X. X is another variable here. You can see the environment, another variable. It is a numerical. So X comprised of 1, 3, 6, 4, 5, 0. And then we provide X the dimension of 2 by 3. 2 by 3. When we call X, we have this. Okay, you can also see in the, but if you do but the R, not from RStudio, R by trend, you will not be able to see the environment. Okay, I think so far. As what about the rest? James, you are following, right? James?
Yes, doctor. Following. Yep.
What about the rest? Are you following? Now it's 5:30. Excuse me, I have running nose. Ernest, are you following, Ernest?
Yeah.
Okay. What about the rest? Tasha, are you following? Tasha?
Yeah.
Okay. Tan Week One?
We'll try again later.
Okay. Balkis, okay? Okay. Just leave it there first. Leave it here first. So those who want to follow can just follow. Anyway, it is in the records. Now it's 5:30. Any questions so far? And okay, just recap. This is R. Okay, and then next week we will continue again. We'll move into array, list, and other, and then this is just basic on the vector, how to create. And then you can also test. I'll share you the bolts and nuts. nuts and bolts. Where is nuts and bolts? Okay. In nuts and bolts, there is also other. You can also use test. Try with this. Okay, this is atomic classes object. We have character, numerical, integer, complex, logical. Yeah, so attributes. How do you create vector? This is how do you create vector. We'll start with C. Is concatenating it. We'll start with C and then you can create. If it's 0.5, 0.6, yeah, it is numerical. If it's 9 to 29, it is integer. And then you can also mix object. When you mix, it becomes character, meaning it doesn't count. So there is the ranking. Yeah? Character is always the highest rank. So when you include number and a character, it becomes character. When you include logical and number, it becomes numerical. Yeah, if you include A, which is character, and a logical, it becomes character. There is a ranking level. This is matrix. Yeah, we've got column, row, and column. No. This is the list. Okay, we will continue again on data frame and so on, and then I will start moving into how you can calculate. I think next week can start how do you can calculate average. Let's see. Average and other things in Excel. And then you can search from the Excel how to retrieve. How you can transpose data. Yeah. Okay. Yeah, I'll go back to this, to your R Studio. We have class next week, right? Okay. Let's see the time. Today is the second.
Yes, next week we have.
Next week we have class. Yeah.
9th of July we have.
Next week we will have another case. We'll give you another case study, and then we'll cover topic 8, which is on big data. I think topic 8 on big data, and then I think big data. I have to check, and then we can also do another R, and then we'll do some analytics. At least descriptive analytics. You can do some descriptive analytics. Yeah. Okay. Any questions so far? This is 5:35 now.
Prof, can I ask the R Studio session that we have typed today? Is there a way to like save it or export the script?
Can. You can save it. You can save the R. It is the file, and then it is .r. And then you can recall it.
Because when I go into file, the save is sort of grayed out. There isn't the option to save.
Okay, you need to save it. I'll show you. You need to save it into a specific file.
Doctor, that means we choose, when you go to file, there's an option called new file and choose R script, is it?
Yes, R script.
R script.
And then you save it in a known file. Maybe you can put into your document, you create a folder, you find the file. Because when you want to call it, you have to find the specific file. You have to find the specific file. And then you have to allocate the specific files in your computer. Yeah. Do you know how to find the file in your computer?
But doctor, when I choose the R script, right, it just opens an untitled
Yes.
window.
Yes. So you have to save that. So it is a text. You save it, you write your code, and then you have to save it as .r. You will save as .r, and then you save in the specific file.
Okay. But how do I save what we have typed in the console?
Oh no, you cannot save that because you have to create the file and then you type in the file first. What you have written.
So what we've typed in console, there's no way to export that.
Yes, unless you copy and paste into the file.
Okay. Copy and paste into the file.
Yes, but it doesn't mean anything because when you call the file, it will go right line by line. So it will not serve anything because in the file, you should have a line of codes. Meaning that there should be a proper instruction algorithm that it follow through. It's still a programming language. It will follow line by line because just now what we did is not by line. We move from creating certain vectors and there is no proper code. I will show this. We can still call R and then the thing that this just now we can still call the function. We can still call the function, but doesn't really, but you cannot combine. You need to put them file by file. Does that answer you, James? Okay.
Yes, it answers. I managed to copy it into Word document. Yeah. So I just copy the console.
Oh, you mean to Word document?
Yeah, at least we can.
Okay, I'll show you again.
Back. We can look back. So I managed to.
I'll show you again. Wait, I'll show you again. Okay. When you here say you will use this file, this part. If you will use Studio, you will use this file. Say you want to say print. You want to say print, say hello world. Yeah, print hello world. And then you have to save. You have to have save. And then when save, it asks to save. And then you have the specific file in your, say, documents. You save R, and then you save as R. Yeah, save as R. You just save, it will be R. So you can just save that. I will know.
So for every command, it can save into the same file also.
If you save the same file, it will get confused. It must be a read because it say print R, you save it as print R. For example, you file, say file, save as this. Say I put in my document. Say R. Say so you say. Let me see. Okay, you say hello. Hello. And then you can say .r. I haven't saved it for quite some time. So when you save, it become hello.r here. So it uses, so this is the file name. You can see file name here, hello.r. So you have to call this hello.r using a terminal. You have to call hello.r. So I need to find where is this hello.r. Yeah. The hello.r. So it doesn't identity. Hello.r, something like that. Yeah. So it is open here. So I need to give instruction. Yes, so this is when you call. Yes, so it is saved in the specific file. I'll show you next week how to use this. Yeah, it's from, this is the terminal. Okay, any other question? James, okay?
Yeah, okay, thank you, Doctor.
I'll show you next week how to call file. Ernest, okay, Ernest?
Yeah, okay.
Okay. Balkis, okay. Tasha, okay, Okay, what about the topics that we covered today? Any question on optimization and simulation and decision analysis? Okay, the class today is recorded, so I will upload in your open learning, yeah. Okay, if there is nothing, can we adjourn for today until we meet again next week?
Okay, thank you, Prof.
Thank you, Prof.
Thanks.
Thank you, Prof.
Thank you.
Thank
Thank
you.
you.
Thank you, Prof.